I did is I went into the other class and started poking at the homework. So if you go in, I guess I should show you inside. So if you go in the Blackboard site and then you go down to class lecture notes, it'll load the OneNote. It may ask you to log in. And once you're there, there's a homework. And then homework 1. Okay. Wait a minute. I thought I poked around at this. Okay. Wait a minute. Oh, I was doing them backwards. I went to the last one. Somebody had a question on the last one. Then I did the next to last one. So if you look at the video for the first class period, that's what I was doing. I was basically hacking around at the homework. So in other words, I started earlier. I should have waited. I didn't know you guys were showing up, or I wouldn't. That's okay. That's okay. I am too. So, so what I did in the last class, I started hacking on the homework. So here's what I mean. Okay, so you can go in here and you can see the homework. So if you click it, it comes up and it'll show up in a window. But actually, the way I printed this is I went to my OneNote and I made homework for 1, 2, 3, 4, 5, 6, 7. And then what you'll notice in there is that they're clipped. In other words, it's the size of an 8.5 by 11 sheet of paper, and I dropped stuff on it. But the advantage for me was that I can just put them all in there and come back, and I can see any one of the homeworks at any point, and like I can come into the classroom and start hacking around on it. Then if you want to see the hacked up stuff, you go to Blackboard. Oh, that's easy. That's easy stuff. Do the best. Yeah. Well, do the best you can for the homework, but what I'll do on the test is I won't ask you to graph it. I'll ask, velocities at a certain point in time or position at time. Yeah, I only want the numbers. So if you draw it and it looks kind of funny, it's okay. As long as you're able to tell yourself, that, okay, I know the acceleration at a certain point.
Also, are you going to be grading it like you did in statics? I'm going to try my best to get it right. Are you grading on the 10th or are you grading like practice?
Oh, on this one? This one, on the homework, it's going to kind of be attempt, but also close. And then what happens is if you're way off, it'll be a deduction, and then you can go back and resubmit. So it'll be something like you might get a 6 out of 8, and it says resubmit this problem and that problem, and that's it. So, but it's kind of more like if I can see that actually that's there, you've got it, even though it's not exactly perfect, it's okay by me. So that's going to be the approach I take. So, and actually, I got a grader this time. I haven't had a grader in a long time, so I don't know what to do about that. I guess I'm going to have to like show him, how to do stuff. So for example, let's do it in reverse. This way, it'll confuse the other class because I told them to come look at the video for this one. Somebody had a question about the last problem, so I started there and worked backwards. So in this one, I'll start this way and work forward. So if I go to OneNote and I look at the first assignment, it says a van travels along a straight line with the velocity in that graph. Construct the S and T and the A and T graphs and take S is equal to 0 when T is equal to 0. So I guess I can just go right below it here. I'll do right below it, and I'll start with the acceleration in time. And of course, the whole thing is to figure out, if you look at this, That's the case. Well, that's pretty easy. So you're looking at the slope. That's just that right there. So it starts at 4. I should have moved the axis up. You know what? Here's what I'll do. I'll say that's t, and then get rid of that. That way I can just say, okay, it goes and then stops. So that's be -4. Now on the test, I might say, what's the acceleration at t is equal to 10? So for that matter, you just look up here and you say, well, around t is equal to 10, the slope is -4. So it'd be just -4. And yeah, this would be an easy one to plot, but at the same time, I don't want to have to look at that, whereas I could look at something like this pretty easy. So that sort of makes sense of what the difference would be. Now the bad one here, S is a function of time. Of course, here, let me get rid of this so I can have room. So you know that, well, okay, is equal to velocity, which means I just draw that over there and you say ds is equal to the integral of velocity dt. Now you could just go in here and take this in here if you wanted to, -4t plus 80 dt. And he said s is equal to 0 when t is equal to 0. 0, so these match. And then this is s and ds. So what you get on the left side is s. Then what you get on the right side is -4t squared over 2, which I guess I could just easily have taken that out, plus 80t. That doesn't look like a... So then the question is, okay, when t is equal to 0, yeah, I've got that. I start here. I guess there's a couple of ways you could think about this. If I just drew a line 80t, it'd be a straight line. So that's not the actual answer. But then I'm subtracting some from it. So I guess, how would that occur? When I initially started, I shouldn't have, oh, I know, Control Z. When I initially started, kind of like that, I think I should be like this, maybe. Is that? Now, if I want to be really meticulous, I could do it like this and see what it looks like. See, this is why I don't want to have to grade this or figure this out. T is equal to 0 to, say, 20 seconds. 20 is good enough because that's where the end point is over there. And then I'll say, what? S is equal to -2 times t squared plus 80 times t. Now it's going to give me a, okay. It's going to give me an error, watch. Okay, so I got to do this. And then I can do plot. Okay, what is it? S and T. Okay. Not responding. Oh no. You think? Is it really slow when it does? You know, I thought this would be a simple process. Tell you what, I have had one experience that it seems like this one does better than that one. Let's try it over there and see if it outruns it. And then S is equal to -2 times T squared minus 80 times T. Now let's plot T. Well, okay. Okay, let's plot. Sorry, let's plot T and S. Okay, there we go. Oh, Okay. Yeah, I did. What? Okay. What did I do wrong? Let's go back and look at, where did this come from? Okay, let's go back and look at this one. Oh, that's supposed to be plus 80, isn't it? Okay, hello, hello in there. Do that. Arrow up, arrow up. Okay. Well, okay, so well, wait a minute. Try that again. Okay. Anyway, try it again. TS. Okay, there we go. Good grief. So I had it wrong. See, just like that, I mean, it goes up above it. That, wait a minute. Does that make sense, though? Yeah. Yeah, I guess it does. However, that is what I drew. That's kind of what I drew. Although mine doesn't look as accentuated as his. Okay. And of course, what I would ask, like on the test, is how far did it go in 20 seconds? Now, there's two ways you could do it. S is equal to minus 4, or I'm sorry, 2, or say 80 times 20 minus 2 times 20 squared, which would be, what's that, 160 minus 20 and 20, 400, so that's 800. Am I seeing this right? No, something's wrong here. 800. Well, here's the other way. Let me do it the way I would do on a test. 80 times 20 is the area divided by 2, which 8 is 1600, it's 800. So that's correct. So I should have gone to 800. Now, what did I do wrong here? Tell me, what did I do wrong? 80, 20. Oh, sorry. Okay. That's kind of, oh well. That's the way life goes. So I get 800 this way. So my point is, I guess you could do this way, or you could just look at the area that's right back here to the left of it. So if somebody asks you, how far did it go in 10 seconds? One, you could go in here and put in 10. S is equal to 80 times 10 minus 2 times 10 squared, or what is that, 800 minus 200, or about 600. Or if you don't even want to integrate it, what you do is come back, and I guess I don't even have to do that. I guess I come back and say, look at the area from here back. The area from here back would be 80 plus 0, and I'm taking the average of the height here. Wait. Average of the height would be, that would give you, that should be 40. So this should be 40 high. So if I take the average of that over 2, that'll be like you took a block that looked like this, and then you multiply it times 10 seconds. So 8, 9, 10, 11, 12, or 60. Let's see. Be 600. Is that what I got down here? Yeah, I got 600 down here. So all you can do here is wherever they ask you for that position, you look to the area, complete all the area to the left of here. That's all you're doing. That's more in line with what I would ask on the test. I wouldn't ask for curves. I mean, you given time you could do that, but there'd be a little bit of thought and delay in it. And from person to person, it might be significantly different. I don't know. Okay, so okay, here's another VT. Dragster starts from rest. To construct the ST during the time. Okay, S and T. And that's it, right? Oop. Oh, wait a minute. Is that because of... Yeah. So he's just asking for the S and T. And of course, all you're doing is you're taking any point, you're looking at the area to the left of it. And so since this is linear, the other is going to be quadratic. So my guess is you're going to have something growing kind of like this. And then what's going to happen? The next thing that happens is it starts shrinking. Now, if you want to put it in there, you can figure it out. However, I'm going to go ahead and say, let's look at it. Let's examine the position at 5. 150 times 5 divided by 2. So I know I should be able to do that, but 375. So I get 375 should sit right here. And then the question is, what happens? What actually happens when you move to the right of it? Let's say at, just case in point, let's just say we want to find the position at 6 seconds. Well, it should be 375 plus an additional, so it doesn't go down. It has to continue rising, but how much does it rise? Well, okay, so the question is what is this particular value? I could do one of two things. I could just stick in t is equal to 6. If I stuck in t is equal to 5, I hope, into this equation, I hope I get 150. And I think I do. I'm going to go with that assumption. But if I put in something besides that, I don't know that I can, let's see. I don't know what I just did. Uh-oh. I better go back to the other version of here. Oh, it already is there. Okay, there it is. It's there. It just doesn't have a label associated with it. Okay, minus 15t plus 225. So let's see. Times 5 plus 225 should be 150. Now, this should be 135. So at this point, this should be 135. So if that's 135, then the added area would be, take the average. Does that part make sense to you? So I would say 1 times this average, which will be 150. I'm going to do it, zoom in a little bit so my handwriting is a little better. plus 135 over 2. And what the reason that's the way it is, because you're looking at a strip of area that's like this, that's added to the triangle already. So this is the 375. This strip is 150 and 135, and it's the length 1. So what you do is you generally go in, take the average, and the area you lose and gain through the triangle is the same thing. So it's a 1 by the average of those two. So this is that integration. There are several different types of integration you did or might have done in the past where you break a little section apart. I don't remember. So if you do that, you should get a number, let's see, 150, 135, and I don't have brackets, but I should. Divided by 2, 142.5. Then add that to 375, and you get S at 6 should be 517.5, I guess. So you go down. So you still are inclining, but I think it starts trailing off. And so then you could say S at 10. What's S at 10? Well, it's the 375 from the area back here already, plus this time it's 5 seconds over to 10. And so the triangle you're looking at there starts at height of 150, declines down to some value. It's 5 seconds over, 5 more seconds over. The next key is what's that height? And that's where you'd have to use a calculator real quick. And instead of putting in 6, you'd have to put in 10. Just 75. So now the area of this chunk is 5 by 150 plus 75 over 2. And so okay, so if I do that, okay, 150, 75 over 2, 5 times it, 937. So the position at 10 is equal to 937.5 again. So that's the type of stuff I'd ask on the test instead of you having to draw it. Because then the question is, does it do this? Does it do this? Which one do you think it does? Okay, so let's monkey with it and see if we can see that. One way you can tell, okay, so if you're doing this and you're integrating 15t with a minus plus 225, because that's what you're doing. Let's just integrate it without anything. So you get minus 15t squared over 2, don't you? Plus 225t. Now, they always talk about concavity, right? Concave up, that term has to be positive. Concave down, it goes the other way, right? Is that right? Do you have any memories of that? So that you're right, it'd kind of arc off. I don't know how difficult or how much that arcing would be. I have no clue as far as that goes. But if you had, you know, MATLAB available on the test, yeah, you could plot that out, but, and some of you might have calculators that do that kind of stuff. I don't know. I don't have any of those calculators. But for me, on the test, all I'm going to do is require you to tell me, you know, position at a certain point. And of course, I would also come in. Now, this part's really silly, but if I said acceleration at 3 seconds, what would you write down? Would it be 30? Yeah. Acceleration at 6 seconds. Yeah. So your plot, if you wanted, ooh, that's anyway. Okay, here. Your plot would come in, it'd be 30, and then it would pop to minus 15 all the way over to this 15 seconds. So it's a fairly straightforward. So everything over here to be minus 15, everything here. So if somebody said a acceleration at 5 seconds, what would you write even though? That's a tough one. Because that instant that he put on the brakes, so what he's done, he sped up to 150, then he started slowing down. So here's your accelerator, here's your brake. That, you know, I don't know, because you know what MATLAB will do? If you list this out, and you know, you have, this is minus 15, I guess this one's 30. What MATLAB does is it takes the average of this number and that number. So if you plot this out as a stepwise function, and then you go in MATLAB and ask it, the answer comes back, you know, whatever 30, which would be, what is that? 15 over 2. So it'll tell you 7.5. But I don't know that that's necessarily right. It's somewhere between 30 and 15. So I don't know the answer to that one. And I don't know that he ever addresses it. Yeah. So it's, I mean, I don't know. Yeah, but mathematically, it's one of those nebulous points out there, which actually causes issues if you're trying to make a test and you're not careful, because you can mess it up. And I've done that before, you know, 10 or so years ago. I'd make a test and I'd just put it together and hand it out, and I would notice, uh-oh, you know, and I didn't know if I wanted to gather the information I got from people, but I spend a little bit more time now than I used to. So here's another one. Okay, so determine the total distance the car stops. T is equal to 80. So that's easy. I mean, okay, so we can construct. So here you go. There's the acceleration. You know, there isn't any acceleration. He's just coasting. So here he's coasting. That's cost, by the way. Then he puts on his brakes. Rise over the run. Rise of 10 over 40, or minus 0.25. Am I right? And then the distance he moved was, okay, this is 400. And is this 200? Yeah, so he moved S equal to 600 feet. If it was feet. Meters here, meters. So he's got a meter up there. And that's it. So on your test, you may have several pictures like this that are just pop off, you know, pop, pop, pop. Or I might just get tired and make one picture and pop several questions out of it. It just kind of depends. Okay, if the effects, oh, why did I do this one? If the effects of atmospheric resistance are accounted for, a free-falling body is acceleration defined by, okay, hang on. I need to rewrite this down so I can look at it. 9.81 1 minus v squared, and that's it. Okay, wait. If a body is released from rest at a very high altitude, determine the velocity when v is equal to 5 seconds. The body's terminal or maximum velocity is attainable at t is equal infinite seconds. That'd probably be a better question but anyway, so what you've got is acceleration is equal to dv dt, which is equal to dv ds dt, which is nothing more than v dv ds. So that's the term you're stuck with. He's got it as a function of velocity, so somehow I have to draw an arrow and draw this and combine them. And you know what? Instead of writing that, I'm going to say g. So I'm just going to say this is g. G times 1 minus v squared is equal to v dv ds. Now, I think what I need to do is pull this underneath here. G ds is equal to, oh man, that's awful. Integrate and integrate. What does he say? He says, wait a minute, he says, is it real? Oh, okay. It's released from rest. And now my question is S pointing up or is S pointing down? Oops, because I know G is pointing down. So my thought process is, yeah, and the positive direction is downward. So this means I go from 0 to some S. And then I go to some V. Now, this is awful. I don't even know why I did this. You know what? I don't have MATLAB. And I bet I don't have Mathematic on here anymore. They take it off every time I come in here. So you know what I'm going to do? Yeah, it does this. So blah. Does that every time. Troubleshoot. Oh, that's not going to help me. You know, I don't know. So the other thing I could do is run back out here and whoops, try to get Maxima, install it again, and then I don't know. I don't even know if I want to go down this path. I'll just download it just for kicks and install it again just to see it disappear. But you know what I think I'm going to do? You know what you got to do? You got to integrate that and work it out. But I don't know that I want to be the one to do it. So I'm questioning why I even put that problem in there, but it's too late now. It's already in the set. So let's go on to the next one. Oh, there you go. Oh, you don't? Well, I thought I downloaded it. Are you supposed to hit that button now? I don't know what to do now. Oh, there it is. So I think the equation is, oh, it's back at the last page. V over 1 minus V squared. Did it download it? Let's run it. V over 1 minus V squared. And it's from 0 to just V, which just doesn't matter. It is what it is. Gosh, it's taking a long time to. Okay, I agree. Install it yet again. Okay. There's a lot of stuff on this. Maybe that's why it gets deleted every time. It's too big. Wow. I'll just let that keep installing. We'll look at the next problem. An airplane lands on a straight runway, originally traveling 111 feet per second when S equals 0. If it is subjected to deceleration to show, determine the time needed to stop the plane and construct that diagram. Okay, this is a pretty decent one here because dv dt is equal to acceleration. He's got the acceleration plot. So he wants you to integrate this thing. And he wants you to integrate it so that it starts when S is equal to 0. It's traveling 110 when that is there. He wants it to stop, but I better just put this in as V. V at some T whatever. So all I'm doing is I'm integrating this V minus 110 on the right. So if I want the final V to be 0, then I get minus 110. Has to be the integral from wherever that is, dt. So here's what I'll do. I'll identify that. 5, that's 5 times 3, right? Nope, 10 times 3, so that's 30. This is 8, and that's 5. 5 minus 5 times 8. Isn't that minus 40? Uh-oh, so minus 40 and minus 30, that's not enough yet. So isn't that minus 70? So at this point right here, I haven't slowed all the way down. I got to get to this 110. So now the question is, how far do I need to go? Okay, this area is equal to minus 3 times T prime minus 20. Or how about we do it this way? I'll do it this way. I'll say delta T. And this will be my delta T from here to here. I'll call this, I'll call this time delta T. That way it's easier for me to figure out. So let's see, if I got 70 and I need 110, need 40 more, which is equal to minus 3 times delta T, which my time past that is what? 40 thirds. Or that sounds reasonable. So, so T itself, that T prime has got to be 20 plus 13.3, or 33 1/3 seconds or so. That's a good problem. I like that one because it gives context. There's enough context to it to know what's going on. Yeah, that's a good problem. I like that one. I guess I've never even looked at that one before. Did y'all get it integrated? I think I've got it installed over here. Finish. Oh, Yeah, 0 to T or 0 to S, 0 to S, isn't it? Oh, is it? Let me see if let me see. Okay, close. I'm going to go ahead and try it. I mean, I'm kind of chasing a mute point here. Because looking back, I'm not sure why. Okay. V divided by 1 minus B squared. I have too many brackets. My variable is V. I don't want to do a definite integral quite yet. Ooh, log. I bet that's natural log too. So minus, okay, minus Lillian, okay, 1 minus V over 2. Oh, 1 minus V squared over 2. Ouch. Is equal to GS. So if I wanted to, I can put a 2 over here, knock that out. I can put these to the power. Do you? 2GS equals to, ooh. Did y'all get it figured? Okay, I think that's what this one had, but it was written kind of funny. Minus, I think that log is natural log. 1 minus V squared all over 2? Okay. Oh, okay. Okay. Well, and then the thing is it comes back in a way that's uncomfortable. And so I moved the 2 over, took it to the exponent. If you do that, for example, if you do the exponent, let's try this. Minus exponent, oops, sorry. Exponent of minus log of, say, 3, you should get a third, right? So this means what you should get is 1 over 1 minus V squared, which means this, I mean, I'm chasing a rabbit now, a rabid rabbit for that matter. 1 minus V squared is equal to 1 over E to the 2GS, or V is equal to 1 minus 1 over E to 2GS, and then the square root. And so as S grows bigger and bigger and bigger, E goes bigger and bigger and bigger too. And I think I'm seeing a terminal velocity equal to 1. There should be well, anyway, I gave you one to think about. How about that? That was a thought exercise there. I don't know why I did that. Okay. Did we do the last one? We did that one. Let's do this one real quick. The motorcyclist travels along a straight road with a velocity diagram like that thing. And then he just wants you to construct this stuff. Okay, so here. Okay, so parabolic here gives you a straight line there. So V dot, which is acceleration, really shouldn't be anything more than 4t. So it should go like this. And if that's 5, that should be 20, right? And then it should flatten. And it has to flatten at 20. Because acceleration of this thing is equal to just 20. So it just goes up, flattens at 20, stays 20. Well, okay, never mind that part. It goes to right here. Past that, I don't know what it does. Then, now is the awful part. This is the part I wouldn't give, because you can't just look at this and say, what's the area of this? That's not, you have to integrate that, I think, unless you know how to do it, and I don't, which is altogether possible. Now, I can figure out the area of this one. So, as you start, okay, so ds dt is equal to v, and so what you're looking at is that ds is equal to v dt. You integrate that for this term, 2t squared dt. So going from 0, looks like and he doesn't describe this. Well, I guess it's okay. So let's assume s at t equal to 0 is equal to 0. ds s, so s is equal to, let's just say in this between 0 and 5. What is that? T to the third? No, wait a minute. Is that right? So it looks like it goes like that, I guess. And then we have the other problem. It's still, since the velocity is positive and not going down, it's kind of concave up, but I'm not sure what it looks like. It's like, so this is cubic and this is quadratic. Oh, well. I'm not going to give you one on the test that has the velocity as quadratic, because that forces you to the equations. That doesn't force you just to do the area integrals. Oh my God, it's another one. How many of these did I do? Wow, but I got a grader. Yeah. Oh no, I'm past the time. Well, shoot. Well, you know what I'll do is I'll pick this up in the Friday, is it 11 o'clock? And then I'll pick it up from here, and then I'll finish it off in this. You'll have all these videos you can just spin through. You probably pick up more on video than you do listening to me, because in one way, you can speed it up. And you can listen at double speed. Several people in static said they had done it and listened to it in double speed, and it sounded normal. So that implies that I talk really slow, which is probably true. Yeah, that's true.